Hi everyone. In this video, I'm going to focus on understanding interrupts and timer. Before diving into that deep into this lecture series, the prerequisition is required. That is 8051 microcontroller. As the basic stuff in the 8051, as we know that various special functions blocks are inbuilt in that microcontroller. These special function blocks, one of the special function block is this timer. From that 8-bit microcontroller, 8051 8-bit microcontroller, as we understood, so how do we configure the timer, the counters, the mode of operations of the various types are understood, and then we may familiar. So before moving to the 32-bit STM32 microprocessor microcontroller, you just revisit the 8051 microcontroller timer concepts. From that concept understanding, here we can easily understood so how the timers in the STM32 is performed. As know that STM32 basic architecture, various versions of various series of ICs are available. From that, the generalized um, thing types of timer is listed here. Usually we have two different types of timers. Simple timer, the timer 6 and 7, or the basic features uh, of the timer, which look like a counting and creating the time delays are available in this timer. But these simple timers are lagging some of the functionalities like generating the pulse width modulations, comparing the outputs, capturing the input signals. These are some of the uh, functions or lag in this simple timer. But other timers are also available in this STM32. For example, timer 2, 3, 4, or the general purpose timers, which are multi-purpose timers that uh, providing the n number of variable functions such as pulse width modulation output, so capturing the input, so qualifying pulse width or signal frequency, comparing the output, and timer with advanced controller. So STM32 timer 1 is the advanced timer control. These timers are made more complicated uses, for example like motor control, the necessary of multiple have a multiple pulse width modulation channels with synchronous outputs. The key features of the timers, if you want to create a longer time period, that is very difficult to make use of the timer. For that, we have a prescaler. So this prescaler allows the longer time period by giving the smaller timer clock frequency. That is our first premost features of the timer. With the help of the prescaler, we can create the longer duration time delay. Another one is the counter, which is accepting the count, accepting the clock pulse count. This is the register that counts the clock pulse. Usually in this STM32 we have a 32-bit. So depending on the timer, it may be vary with the 16-bit or 32-bit. Then periods, the number at which the timer will stop counting and reset. As we decided the number of uh, count, we need to fix on that register. It will decrease step by step. At one time, it's going to 0. So we have some registers to monitor the period. At the time, the count stops and then reset that timer. Pulse width modulation generation, as we know that most of that uh, motors and LED controllers are done with that pulse width modulation generation. So it's a timing device, can produce the PWM signal, measures the timing property of an external signals such as frequency or pulse width using the input capture. So output compare when a predetermined count value is reached, initiate an event. So already fixed that value in the routine program. Once if it is initiated and reaches the count, then automatically it switch over to some other event to initiate. How do we use that timer in the various applications? Here the simple examples is illustrated. So whatever that functions, whatever the special functions we are going to utilize, we start with that simple program. So LED program or motor control. So in this examples, timer to control the basics of LED and create a time delay. So how do we create a time delay with the help of the timer, which is represented here? So what we have to do is, first of all, we need to start the timer clock for the desired clock frequency. For STM32, we have some frequency width. So we need to uh, set the desired time clock. Then we start the set up the how much time we need to require, whether 1 seconds or 2 seconds time period, that has to be set up the timer. Sometimes if you need a higher longer duration, you use the prescaler period also. After setting up the timer, we turn on the interrupt. So after that time's over, what will happen, what we need to do, that has to be turn on the interrupts. For example, in this LED program, so we have a turn on and off, on the LED and off the LED. So once the initiator turn on the interrupt, which will start when the timer goes over, it's written back. So routine for interrupt service ISR indicates which interrupt they handle and toggle the LED. So this is the simplest example of creating the time delay for LED glowing, LED blinking with the help of the timer. So next we move on to the STM32 interrupts. As we know that interrupts are nothing but disturbing the uh, continuous sequence of routine. So as a microcontroller can react events asynchronous to interrupt, which eliminates the need for the continuous loop for peripherals or sensor status check. So the process switches to an interrupt service routine to handle the event and the interrupt is triggered, pausing the ongoing execution. We have three different types of STM32 interrupt. External interruption, as we know that the user or customer has to give some input to that system. The service, continuous process is going to disturb and accepting the request from the user, doing some work and return back. That is the external interruption. Timer interruption, as we uh, look into earlier timer interruption in the previous timer topic. System interruption to is comprise the fault interruptions usually, and it's the system is tick timer is going to interrupt the service. How do we handle the STM32 interrupt? The interrupts need to be enabled. Nested vector interrupt control. First, we have to enable the vector interrupt controller. Once if the vector interrupt control is enabled, at that point interrupts actions, the capability know the interfere the administration routine is to run. Once interruptions are typically time sensitive, it need to be quick and effective. Clearing the interrupt flags. Once the interrupt occurred, it's the flag is going to continuously monitoring. Once if the clear the flag, then it's come out of the interruption. Otherwise, it's going to until otherwise it clear the flag, the interrupt is going to uh, um, operated. So example, pressing a button is the best example for external interrupt. So how do we make the external interrupt? We connect one switch with that port, any of the port pin. That port pin must be configured as an input configuration. Once if we press the button, this press the a signal passes to that system that in a continuous routine is disturbed. Then once if the press is released, it return back and start continuing the routine. So this is about the interrupt handling in the STM32. So thank you.